Good morning again. Good morning, everybody. Namaskar. This is Suraj Singh from Bharat, India. On this day, May 28, 2021, Friday. This is the second video because previous video was interrupted after 1 hour. So I'm just going to continue this talk, and this talk is continuing. And issue was I was talking of stairs, and that was talking of this one, as well as I was talking of, you can say, this item. And this was in relevance to my issue of longitudinal staircase item. I'll explain what I was talking of. I was talking about this foundation, which is a continuous beam. This foundation design is not like footings, independent footings. This is like beam frames, and that is, it's like that. Beam frame footing. All footings are connected here. All footings are connected. You can see this connected, and section of this footing is like that. For example, it's like that. Or this, for here, this one, and this one, that one, and for this is this one. Width of column is 30, this beam is 30, and there is spread here 700 only. This is 200 projection, this is 200 projection, this is 200, and this is 700. So this portion is beam, this is spreader for load, and we can see that stair foundation beam is here, and this one and this one are same. Details of, it's like, combined footing. This is not two columns combined footing. You can see this is all columns combined footing, or you may say I am considering this building as a stool, and this is framing of bottom of steel stool, and here is sit on that stool. You can take that way just to understand phenomenon. Then you can say I consider this as this part. I call this damper. So whatever horizontal acceleration due to seismic action applies here, this can resist that along with this. And this is not like other footings. Means here main point is that in footing we consider, in a isolated footing we consider this span whatever comes here on this side, and we say cantilever moment below due to upward reactions. We calculate cantilever reaction here, cantilever moment, and then here that cantilever applies only for this portion, 20 centimeter, just 20 centimeter. And if there is any upward reaction here, whatever is that, it applies to only 0.2 meter, and which is too small, you can say negligible. We can say that this cantilever upward reaction is negligible. There will be negligible moment here in that case, and negligible forces too. So you may say that after taking this area of foundation to spread load, we can ignore that very small bending moment, because whatever action comes at WL square root 2, L is 0.2, and if L square is 0.04, so you say it's ignore it, and just consider this beam for purpose of calculations and movement. And you may say that, for example, I calculate according to God, but just for guidance purpose I'm giving this point and this point, this column to this column, and this column to this column. You can see moment are there due to upward reaction, but because it is fixed, like its fixity is continuous here, in place of WL square 2, though this is more, maybe 5 meters, or whatever, but WL square over 20 can also be applied. WL square 16 can also be applied for rough calculation, or W square 12 can be applied, not W square over 2. You may say that there is much reduction, even span is more. There is much reduction in bending moment. That benefit we can use. Maybe otherwise there was a foundation up to here, and there was a foundation up to here, and then we had to connect using some beam also. We can't avoid that. So this whole beam, this portion acts. First of all, it is strong enough to resist bending moment. It's strong enough to use very nominal diameter reinforcing bars, 12 mm and 8 mm, and this is also strong enough to provide good resistance, as well as, you can say, to fill in complete volume from formation level to plinth level. Means there is no requirement of any plinth beam, there is no requirement of any tie beam, and there remains no requirement of filling either block work, block wall, or brick wall. So everything is filled in form of this foundation, and there is no stub column in this. Main column starts from here. So there are so many benefits of such type of foundation. You have to think that way. You may say concrete is more in this. No, you may say that instantly, but if you calculate, if you work out, you will find that you are going to install shuttering, formwork, you are going to install complete like bolts here, tie bolts, but that is going to be reused for columns and upper floors, and benefit is that you are not going to use any brickwork or some other material in that, and if you require by certain treatment, this portion of this, either portion, if you say, for example, here I say maybe this 1 meter, you can say, if you see this 70 centimeter axis here, you may use say 50 centimeter for water reservoir between these beams by applying treatment, permanent treatment in the surface, horizontal and vertical, and you can say take water pipe from supplies and directly put here, and from there it can be pumped to your overhead tanks on roof, or if it is pressure water supply, you can pump out it. That could be another benefit. That's main point in this. So just for explaining of justification of this, I did that. Now this skin reinforcement has to come here, main bars are here, going down. Of course depth is almost same as footings. We have 1000 from plinth level to 200 here, 1200 is normal depth. We can use this, and this, once it is continuous, bearing surface that you get in this, is very much considerable. You can see this whole bearing surface, all this is bearing surface. You can say, you can find bearing strength, means you have to calculate strength of this foundation in many factors, shear strength, safe bearing capacity, bearing, etc., whatever. You have to clarify. This is this is a uniform answer to all your problems, and all this portion, even if this is not fully embedded, your embedment will be up to ground floor or plinth protection. even if this is seen on top, all this will be filled, all this will fill, and you can fill using sand, not necessarily you fill with clay or other fill material, and you can start from this columns, and when this frame is horizontal, all this frame is horizontal, and you can say it acts as structural unit in both directions. Force may be coming from this end or from that end or from this side. All this would act in a way total load of building is acting on this area in these beams, and maximum 0.25 of that mass we take for purpose of seismic resistance, for purpose of finding seismic resistance. That force of 0.25 weight is well balanced by this type of system, because it is very rigid in that way. There is no individual footing that can move, and uniformly it will move. And also we can check axis here. You can say, we can find if it's not symmetrical, if it's symmetrical is better, but in this case, for example, it's not symmetrical. We can find CG axis in both horizontal directions and vertical also. We can find maybe that axis is here or here, and then we can find out moments due to upward reaction on this hole and proportionately distribute those here. It's very normal, and how many percent of that we have to take this and how many percent of that here, that size of this can decide. Maybe 60% or 55% apply from this side and 45% apply from this side. Based on that we can find moments and shear from both. That's what a guide I can just telling you. How you do your software, you can do yourself, no problem. And this reinforcement is nominal, means 12 mm diameters. This bars can be taken up, and then of course, starting rings here, you can do same. A superstructure is same. There's no major difference on that. Easy provision of course this will be rings, so big size you have. So you can take this, or you can also take two rings, one ring outside and one ring is here, and the skin reinforcements are here. And you may put some reinforcement here also. There's no problem, there's enough gap, and you can tie that up. No need of even horizontal bars for holding that reinforcement. And you can just put up that here, just put here, you can put here also, and here also. That is so easy, means not problem. And also in here, that's the beauty of this. But my intention was to tell about how to work on that, not to just design explanation. I just give a common sense answer. Now we'll go to this, and then also we will go to this one. This is that architectural plan which requires this, and my talk point is here, this portion. We have to go up, come down, or whatever way. Two flights are here, and we have to think of how to form a staircase, work in that. This is longitudinally oriented, right? And this means this is framework of the stair. The structural framework at, you can say, at floor level. And intermediate would be at this landing point, which is not shown here. What do you think? Similarly, here it is. This is structural mechanism at this level around, and this is landing beam here, must be no beam here required. So one beam in between these two columns, this and which is not visible, that is landing beam, and structural floor mechanism up and down both. That's what it's designed for. And this waste slabs and steps we have. So let us see what our writing says. Says that checklist for RCC longitudinal staircase works, and that is here. Let us read and understand. It says conduct in-depth coordination on drawings for relevant involved activities, which is we have to do. Conduct in-depth coordination on drawings for relevant involved activities. Actual details pertaining following up settings should be charted out clearly for communication to site, for an error may mar site work in staircase formworks. Setting of lowest beam can be carried out in one go easily, whether or not it is monolithic with grade slab. You know what I'm talking about? We are talking about here. Yes, we are talking about this one. Or here, this is that beam where stair starts. This is at first level where stair starts with. If there's a basement, it's from basement, or if there's no basement, from ground or plane. This is beam connected to this structural beam, and also connected to the structural beam, and it from there goes up. And also it says setting of lowest beam can be carried out in one go easily, whether or not it is monolithic with grade slab. Consideration of columns is a little tedious job. That's what I say. Consideration of columns is a little tedious job for a decision that requires to be reached about whether stage casting of column or full casting, allowing insertion of dowels. Stage casting in all respects is recommended, though it takes time but easy for steel. The stage casting of columns shall work better for ease of working, particularly those columns which are at landing. Most importantly, tell about that, because columns that meet at structural slab level won't cause any problem. It's for landing columns. Stage casting of columns shall work better for ease of working. And then setting of first waste slab. Setting of first waste slab requires dimensions of waste soffit. Dimensions of waste soffit which we have to provide. It's very important part. Setting of landing beam slab requires dimensions of soffit and beam soffit, upstand or downstand. So what about dimensions that is talking of? That's very important point we have to consider, and that is here. These dimensions, for example, we start here. For carpenter who works on site, that person knows this dimension, he has to provide plate or combination of plates here at waist. What should be dimension of that must be worked out, which that person knows. You have told him already. This dimension is very important, and this dimension means this dimension also is very important. If this end is considered to be reference line, so this height is there, no, indeed, because of height is known. How it is known? Because this height is known. This height is known. This height. And we know how many risers are there. Whatever number of risers are there up to here, this height is known. So this height is known. When this height is known, we can say this height can be known from shutter dimensions, from drawings. So from here we can come down to thickness and say this is our dimension for bottom. And from here this dimension is to be given to that man, so that When you have this dimension, you can also find this dimension. There's no deal with that. It's easy, and you can give this dimension. Similarly, on this end, you have to give this dimension starting from here. It goes like that, and like that, all dimensions can be given. For example, this dimension is this much, and also same repetition they have to do. Dimensions must be cleared. That's main point here. Dimensions must be clear. Now, when dimensions are clear, now we'll go to setting of landing beams. Slab requires dimensions soffit plus beam soffit, upstand and downstand. Setting of mid landing requires dimensions soffit, but I explained to you. Now, setting of second waist slab. Setting of second waist slab requires dimensions of waist of soffit and beam of slab that we have seen, because second waist goes to slab, and that has to be connected with. Okay, just let me please. Okay, sorry. So setting of second waist slab requires dimensions of waist soffit plus beams and slab. Setting of floor portion landing requires slab dimensions in line with main slab. Okay. Setting of upper structural floor beams that constitutes surrounding beams as part of framing. Ensure correctness of riser and thread dimensions being very significant. Ensure correctness of riser and thread dimensions being very significant. Ensure structural floor height. Ensure structural floor height to structural floor height matches with riser size. Summations or number of risers multiplied by size of risers. In general, calculation and setting dimensions is a cumbersome process for staircase work on site. Now, being design issue, better way is fix sizes of risers and treads to work out floor height and staircase envelope dimensions. Working foreman or charge hand carpenter requires full details that either junior supervisors or surveyors on site may not rightly communicate. Check whether or not all required dimensions are indicated on AutoCAD drawing. In case of some important dimension missing, use AutoCAD soft copy for charting out required dimensions. It is not a tedious job. It is not a tedious job by AutoCAD to work out such dimensions for site use. Calculating sizes using formula shall not be much supportive. It shall be inconvenient and sometimes difficult. It is significant to note that carpenters shall require relevant dimensions necessary for setting out formwork in 3-axis dimensions. Check whether or not supporting system scaffolding for stairways is consistent with check whether or not supporting system scaffolding for stairways is consistent with requirement of design. It's easy to work upon if this system is supplied by proprietary manufacturer or it requires to be designed on site using traditional methods. For explicit explanation, it's better if whole floor plan be worked out indicating supporting system based on proprietary dimensions, catalog or others provide. It has been observed that many adjustments are made on site for such purposes. Check whether or not complete stairways can be poured in one go or in 2 stages. It is better. From controls viewpoint, check all reinforcing bars and have those placed in right locations. Check all electrical inserts that are in place. Check all risers are in right location or well anchored using middle anchorages supporting system. Check whether or not reeling inserts required at this stage or preferably not required as embedments. If required, fix them. Check all forms are fixed properly and well secured. Inspection to be conducted for all items. Plan for pour whether or not first portion separately and second portion with suspended slab or planning pour all with slab as an option to be work decided depends on how it is best. Generally one or can say first landing, when I say portion is landing up to landing waste slab, first is done and second one is done with slab above slab. This is generally happen, but there is no such mandate. Well, it's better you do slab with landing and waste then other waste and slab. Reinforcing bars, particularly requirements that ensure reinforcing bars are clean and free from rust. It's very important point I always stress because I have seen people least bother about rust and even engineers don't point out on site. This is fortunate, they accept everything. On all projects I have been experiencing this while walking on roads and see generally all the steel is rusted and they don't even raise questions. They don't even ask and use that. It's really stupidity, I can say. If engineers can't speak, what for they are there, I don't know. What's the purpose of engineer if engineers can't speak? They can't fight with contractors or us. Just submit for everything. It's not engineering. That's what I say. Engineer must have quality first. No quality professional. If engineer cannot point out, he's not quality professional. Ensure reinforcing bars are clean and free from rust. Ensure sacrificial anode is fixed if so required. It's just an option, no mandate, in which case non-epoxy coated bars should be included. Ensure that electrical continuity check shall be conducted if cathodic protection mechanism is installed. Ensure touch-up paint in case of epoxy coating is applied continuously on reinforcing bars, and no cathodic protection is permitted on epoxy coated bars. These points are very common for stayers, and it's just general. It's not necessary that you can do only this way. I have explained that there must be railing and you have to embed railing pieces or now or later, and also we have to see that reinforcement which is shown on generally in stair, you can change that. You can take complete compression reinforcement also you can provide if your design says 12 mm bars are okay, and also that it will act. It's not necessary what has been done so far. We have to provide that way. We can change our design according to what you think is right. And also we have to provide nominal steel in steps, and it is recommended that never cast steps separately to waste slab. Both must be poured, both must be done simultaneously as monolithic. So when you do formwork for slab, say staircase, waste slab and landing and sides, when you complete with steel and that, you have to provide steel for steps and provide additionally you have to provide risers only. Just keep in mind that only you have to provide some arrangements so that your risers are connected together when you put shuttering on that, so that they cannot move from their positions. Means you need one piece of long timber on waist which connects all these risers in positions. These risers are connected on sides and also with that long middle portion of middle blades, timber piece, heavy piece, and these vertical risers are just put in position and level, so that when you cast waste slab, these steps are also cast. At this stage, it shall be better. It shall be a kind of, though it will not take any structural loading, but it will be part of monolithic RCC member. That's requirement. Generally, it doesn't happen here. People sometimes use bricks on waste as steps, which I don't think is right. Means it doesn't go anywhere, but it's not structural work. And also, you can say this concrete is not very fast. It's not a big quantity concrete. Even if your waste slab is 20 centimeter thick, it's just very small quantity is used, not very heavy, and this pour is not very fast, particularly when you, because it's inclined floor, inclined, and it takes some time. So we are not covering all, we are covering only bottom with shutters. It's really, you can say, better pour if you go slowly on this, but correctly. Generally only 1 or 2 pipes, 3 pipes come from electrical, and I think in waste hardly one bulb is kept for lighting. And there is a window also in the staircase on towards landing end for purpose of lighting and ventilation. And if you want to provide some other facility, I think there's no major in that. The railing is there and there's roof cover, stair cover we call that. So only finishes of waste would work, and only point is provision of good reinforcement so that it is better stair. Quantity is less and steps filling takes some time, which we have to understand that point. So these points, as I told you, are worth understanding. And continuity of stair is a must. You cannot change vertical rises. You cannot say I keep 1 millimeter different or 1 centimeter difference. It's not permissible. All risers must be equal height. Riser is equal height, and treads must also be equal width. And of course, other requirements are there. That is in architectural work, or you can say slip resistance and this and that, which is different part. And curing is also important on stairs because water can't stay there on waste. So gunny bags, or you can say Haitian bags with norms, or you can spread curing compound. That may also work for a couple of days, like that. We will talk when you do concrete pour. So I should close this file of stairs. No need now. I'll close this one. Then I'll just close this. Yeah, let us take for this case means okay. Plan structural and make a house plan. I close this also here on it. So you can see that now most important work in buildings, most important work is suspended slab, which is, you can say that tells you that building is being done. In fact, only suspended slab tells us building is being done. Though it's not fact, but we say it is a cover. Just think of a person, just think of an engineer who is young, new, and for first time that engineer supervises job or does job as engineer, site engineer, and that engineer supervised team and slab is cast. During casting itself, that engineer would be scared of collapse of from work, though it won't collapse if everything is okay. Okay, that's first point where that engineer would be nervous. Second point of nervousness comes when 10 days or 14 days are over. That engineer is concerned that this is going, shattering of form is going to be open, and really that engineer is very much serious. Oh my God, what will happen? I don't know. Because in his mind, picture is it may not come down. Though it doesn't come down, but a person who is new, of course, can think in that way. No lack of confidence, you can say. What we say, in general, we say that there is a roof on your head. People call like that. Means they convert slab into roof in talks. I have a roof on my head, so I'm happy. You can say roof on head means happiness, means a kind of, you can say, contentment. I have roof on my head. I have something to belong to me. I'm not isolated one. I have roof means it's my house and I own it. So whatever type it is, howsoever bad or good it is, it's my home and I am happy with this. This is general tendency of people who are lucky enough to have small or whatever sort of size of house. And therefore, I can say slab means happiness. Can you understand? It's not technical happiness. It is assumption. It is a feeling with common people for whom house is a dream. So we are talking of some item which is very much significant in eyes of people of this country, and not only of this country, in other countries too. So we are talking of slab. Slab means wonderful slab, not ordinary slab. Structural slab, and slab means beams with that. Simply slab is not enough. Beams and slabs and some part of columns. Interesting one to say that we consider this so strong element, strong member, your slab, that gives you greater confidence. Slab is greater confidence of structure. Once you get it, you feel something, you get it. I am under sun, but under roof also. I am safe in rain, and I am safe in bad weather conditions. Because when roof exists, slab exists, for sure walls would exist and other items would be existing. That is the important point in slab. Therefore, we have to think in greater understanding value of slab coordination. Slab coordination is an exclusive item in construction engineering where a lot of input are done. Lot input. Slabs are, downstand slabs, means downstand with slab. In some cases, there may be peripheral upstands and in middle downstands, or there may be something sometimes in roof or in the highest floor. There may be all upstands, and between these beams which are in upstands, there could be some fill of light material, but generally, in upstands, in roof also, do not apply. In roof where terrace is to be, accessible terrace is to be produced, constructed, downstands, but downstands are very general. Very general downstands are in construction designs of buildings roofs, building slabs. It's not only concrete. We have to keep into our mind for slab, suspended slab or level slab. There are so many other coordination issues caused together. Architectural drawings come into play, structural drawings come into play, and all services drawings come into play. And those drawings first must be worked out depending on what civil and architecture requirements are, or what they want you should do. You should remove that. That point you have to understand. Electrical service, mechanical service, or HVAC service, plumbing service, or you can say some other service. Sometimes we used to say building management service. Nowadays this is something equivalent to that. Maybe they call it, what do you say exactly, it should be, I'm not remembering. Yes. You can't say diplomatic service as well. So service which you are getting through agencies are of utmost significance. Utmost significance. We can't go against them. These discipline services have to be coordinated together first. These electromechanical discipline engineers have to coordinate these services together with each other's facets, each other, interfaces, each other discipline interactions or coordination, and then to coordinate with structural beams if there is some clash and which requires handling. I think if these are coordinated enough, it can be wonderful. Coordinated in the sense whatever rooms we have, services to those rooms should be precise, not precise. So my dear, when I'm speaking about slab, there should be complete coordination of slab before attempting to start work of slab. Material shall be approved, that's different. How to do slab work, this is, the kind of pragmatism, that is a kind of pragmatism. What I have to do for slabs, we have to prepare all shop drawings or fabrication drawings or whatever detailings are there at various levels of floor. Those must be worked out together, keeping in view all machines we have to install, or fans we have to install, or extract fans or ceiling fans or lights, whatever we install, or you can say load distribution, electrical load distributions at every floor where sub-main distribution boards are required to be placed in. A complete coordination is a must. Coordination of high power, high voltage, low voltage must be shown at every floor, or if the floor is not done, then how? When you don't have this coordinated drawing, you may find problems on site. It's better to take some time for understanding and let those people, electromechanical engineers, sit with you to make sure that every information is available for charting out routes of these services on this floor according to electrical and mechanical specifications. This is very important item. Very, very important item this is. You have to keep in mind that if coordination is not done properly, your building cannot be done properly. Okay, then we can say, now what to do? Sit down, see problems, talk them, call them, and find a drawing which shows services from every discipline. Once you have coordinated drawing successfully done, You can follow work. Now, coordination drawing for relevant involved activities, as I said, we have done it. What you need actually, you need all the structural drawings which are already there of approved status. You have all architectural drawings of approved status. You have coordinated details with you. You have setting details with you. Setting lines, building axis, columns, grids in both directions. Building axis is very important control point. Axis is average, location of axis like CG, CG line probably or near CG, both X and Y axis. Then setting out, you have to chart, you have to start that. For that you have to confirm information to your relevant part, your staff. Generally surveyors are available on site, land surveyor, and they do this theodolite job. Theodolite is used for this purpose. Grids have to be formed. Before that you must have some access on site. That access is very important. You have to understand this point, that you have to understand the slab is ultimate result of your work, and it has to work that way. And if it doesn't work that way, so there's something wrong, some error, and you also have to pick up that. If you can't pick up that, you're on the job. So you have information, complete information. You have to prepare for, you have to provide scaffolding below. You have to provide scaffolding from here. This means it's not necessary that your areas are regular, symmetrical. Generally, we have to make drawing for system that we are going to use for support. We had to use sometimes props, and before that we use timber bullies. In our country still they are used. Irregular size timber bullies people use, or you can say vertical logs, thin logs we use. Now then came propping system, which was different also, which required some artificial bracing around. But then came structural system, and that's called cup log system, which grid is almost 2 meter by 2.4 by 1.42 in both directions. It is say in one direction it is 2.4 meter, in other is 1.2 meters. So that kind of, you can say, kind of a size of ply. This means we should have some drawing prepared on sheet. We have to prepare a drawing to put in that logs, props, and whole system, so that it fits in that drawing. And it's much better because the same dimensions can be allowed for whole area. For example, I'll show you drawing here. This is that drawing. Say for example, this is that drawing. Oh. 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 Sorry, gentlemen. Listen, that with gastric sound, gastric, it's releasing that. Oh. 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 Sorry. I'm sorry. Oh. 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 Okay. Let us try 5 minutes only, I think. In 5 minutes I'll explain to you. And then we'll close this video. For time being, oh. 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 Now this is a plan, you see, 10 meters by something 14.5 meters. 10 meters by 14.5 meters here. You know, grid 1, 2, 3, 4 and A, B, C, D. In this case, I'm not shown any building access. No problem. We can consider one grid or this grid or this grid or this grid, whatever. Main axis or control axis. Or we can take this grid itself to, or you can say we can take any other grid as axis. It depends on how we work. Accuracy of measurement is important. Means you have to take reference grid. For example, I take this and then measure from here, all this here, not from there. Suppose I take from here. This is I established here. And from here I will not take. I will take again from here and go to that one. Again I will go there and take that one. So in that case I can say I assume this as building axis, or I have to assume some axis here, some axis here and some axis here, and I use that for purpose of location of my points, setting out of my points. That is criteria, because if you take from common control, you will not accumulate error. Here suppose I take some point from here, I go there and I take this, then I take this. If I take from here to here, then go from here to there. So suppose there is 3 millimeter error here, it will accumulate in that. So I don't accumulation of that. Well, this is just for guidance purpose. But now I'm saying is, I'm now going to start shuttering, and for that I need my points for couple of system. And this is completely non-symmetrical area. I have done separately for staircase. Now what I say, suppose I want to start from here, say, I want to start from here. This is big area here. I can start from here, or you can start better in this case. I can start from here. Let us say it is good room unit. I start from here. There are the dimensions are 2.4 meter and 1.2 meters. So this way or that way I can go both ways. So I say okay, 1.2 meters here, then 1.2 here, 2.4 and 1.2. I put drawing like that. I put a grid according to grid sizes given by that manufacturer. So we can say we can form drawing here in all this area up to where our grids can reach without clashing with these columns. And if some area is left, for example, some is left here, or some piece is left here, for that portion we have to make shorter pieces we have to demand, or we can make some other arrangement. Ultimately aim is we have to see where our boys for this couple of system or carpenters who do it, they must know where to start and how to do it. So, and this is not stops here. When you complete here, you have to move into this portion as well. You continue that, don't stop, continue in this portion also, continue in this portion as well. Wherever you have to see, go completely do it and don't stop. And also, if you come here, come in, because wall doesn't exist at a time. You come here in this bedroom and continue for toilet area. Wherever slab is to come, you continue that one. Go into this area and make drawing. Go into this area, make drawing. There's no wall here, so you can take whole area. Then you can inspect where what I've done. You can join all those points to make them rectangles of 1.8 into 2.4 into 1.2, and based on that you can demand material. You want material, you can compute out how many grids you have. Then also additional material of pieces and corners or something else are left out of that, so you can use that drawing for material requisition, as well as that drawing can be used for layout. Those people will not come to you again and again to show you layout. This is for supporting system, that's one. And also this is for, then you have to use upper materials. You'll get them, whatever system available, they may give you your own material or you have to use your own material. That's another point. But supporting system is there, then you can put standard metal systems on that, and so that on those you can work out how your plywood is placed on them, on those main members, original members, and also your other activities for formwork are done, bolting is done, everything is done. So you have a base now. You can continue for soffit work, slab soffit work, beams soffit work, beams sides work, and likewise continuity is required. System is clear to you what you have to do. Then of course first you have to start soffits of beams, because there is drop down beams, and then you have to place vertical soffits on beams, and you can say important point is that, as I told you, so I can now say something about what I did in my life. I used to do like that. Let me read something here first and then we'll come back. So I said, conduct in-depth coordination on drawings for relevant involved activities which we have done. Ensure that all structural and coordinated services drawings are ready for construction that we have done. Actual details pertaining following settings should be charted out clearly for communication to site. For an error may mar site work in suspended slip case that we have done. Setting out all grids in both directions are accurate, we have done. All supporting systems scaffolding drawings are ready, duly approved, certified by designer, manufacturer, and we have done. All access scaffolding details must be ready, that we have to take care of, means temporary work around system. It should be clearly done, how people shall circulate, how to walk, because we have to go to top slab work. Have clear access, safe access, stepped access, not just ladders but a stepped access. You have to go. And stepping type ladders must be ready wherever required. Materials for all involved areas ready for safe working in and around portable areas. Means when you are going to demand for material, it must be kept in mind that first set of periods is very critical. All supporting system scaffolding drawings are ready, duly approved or certified by designer. All access scaffolding is ready. step right lighters must be ready, metals for all areas must be ready, self-working and all around. For every areas, metals for all areas must be ready for installing purposes. All the installing bars are ready for this. So means you can say you will take this in details meter. Now because it's already more than 1 hour, I would simply say that we have to take care of this type of work in our profession. The slab is very complicated item and it should not show defects. It should not show, you should not tell that there was no quality controls. It should result in profiled surface according to design. And that's very important part, because if there's something out, the wrong beam is out of line or slab is out, it may cause permanent problem. Beams may be repaired, but beams also can't be repaired in one setting. We have to take care of our considerations, all these points before doing something else. I'll take up this again next time because it's very important, and we'll discuss it at length, because shuttering for formwork, shuttering for formwork for slab have got many inspections and stage inspections. You can say actually whole story is very important, but some actions, for example, so now I think we have to close here, and hope you understand this, enjoy this. Thank you very much, gentlemen. Hope we'll meet again and say it, discuss it, keeping in view many issues, and can say I can show you again. We did try to consider this point well, and we have to take plan accordingly to understand what we are doing, and then we can say here we close it.